Welcome to my channel. Once again, I'm shifting directions. Big time. I love working with cheap electronics because, honestly, I can be pretty destructive. In the last few weeks, I got my first LCD and burned it almost immediately. Then I fried my Arduino development board. Thankfully, my laptop's USB port survived. It took me days to accept that the Arduino board was truly dead. I even tried ripping off all the components to salvage something, but the pins tore off in the process. I tested the LCD with another Arduino board, and it behaved strangely. Thinking the I2C extension board was the problem, I soldered pins directly onto the LCD header and burned the second Arduino. Then I got sick, so everything paused while I waited for new chips to arrive. This time, I chose CH32v003 chips. RISC-V based. They're cheap, but they demand more labor. I have to solder them onto a PCB myself. It's less reliable, sure, but I'm confident that enough practice will eventually pay off. Hopefully. CH32v003 is often called the cheapest MCU on the market. Oddly enough, its development boards are priced like normal ones. Still, because it's based on the RISC-V architecture, I figure what I learn here will apply to future chips from various companies. ESP32 and Raspberry Pi Pico have RISC-V variants too, and I refer to their projects often. WCH actually provides decent support for their products, even if the company isn't very well known. I'm not trying to take a niche route. I explored other ways to compile and upload code. Arduino IDE can do it, and since WCH advertises new RISC-V compatibility, I hoped it would just work. Unfortunately, Arduino support from WCH doesn't function properly on my Windows system. Some tools even need a Linux GUI environment. In the end, I decided to install a dual boot system on my laptop. At this point, I've installed the official IDE, Mount River Studio, plus Arduino support libraries. I originally planned to walk through compiling and uploading code to CH32v003, but after reviewing the template, I scaled back. First, I need to get comfortable with Mount River Studio, explore Arduino support, and peek into the RISC versus new toolchain. So, let's start from the company behind the CH32v series. WCH. The chip family appears under the MCU Society section. In the RISC-V category, opening the page, you'll see a list of models. The very top one is the latest, the CH32v317. Clicking on it brings up the datasheet. A quick look at the system block diagram gives you an idea of what's new and what it offers. Compared to older models, my chip, the CH32v003, has no Ethernet and no USB. Next, let's check AliExpress. I often search for unusual ICs there. When I search CH32v317, I get a short list. Probably because it's still too new to be widely available. The chips cost nearly CAD $4 each, so they're not exactly cheap. The development board goes for about CAD $17, plus possible shipping tricks where sellers hide costs there. Now compare that to the CH32v003, around CAD $10 for 50 units for new shoppers. I paid CAD $3.50 for 10. The point is that WCH clearly intends for this chip to be inexpensive. And it will continue to be. Since new chips keep coming out, CH32v003 is great for beginners. And many software packages even offer free student access. The chip is tiny, though. To make it usable, I need a breakout PCB. Back in the datasheet, I checked the package type, TSSOP20, and found a matching PCB. After soldering the CH32v003 onto the PCB, one question remains. How do I upload code to it? The answer is a programmer. WCH provides the WCH link, which works with all their MCUs. So far, I'd say a CAD $3 development board for CH32v003 is a great deal, considering the chip itself is only about 40 cents. The USB port, indicator LEDs, reset button, and everything else easily justify the $3. I'm still struggling with soldering, but hopefully I'll finish a working board without too many casualties. Moving on to software development. The official IDE from WCH is Mount River Studio, and I'm using it under Linux. On the download page, there's also support for the RISC versus GNU toolchain. WCH supports Arduino IDE as well. You can find the extensions on GitHub. I'll cover those another time, since each environment has its own workflow. I've already installed Mount River Studio and created a project. The project creation window shows a long list of MCUs. I selected CH32v003, then chose the specific variant, CH32v003F4P6, which matches my TSSOP20 chip. When I clicked Create, Mrs. generated a full template. Compared to Arduino, where a simple project only needs a single .ino file with setup and loop, Mrs. produces many files by default. The developer's entry point seems to be main. See under the User folder. I tried removing unused files and keeping only the ones that prevented build errors. But even after fixing all the errors in main, the build still failed. That tells me the template is designed as a complete system. Even unused features stay part of the build, probably because the template reflects the full hardware capabilities of the chip. Other MCU models likely generate slightly different templates depending on their peripherals. Looking at the folders, Core folder contains the RISC-V core files, which matches WCH's claims and what I expected. User folder is where most development happens. System files, interrupt handlers, configuration, and main, which feels similar to Arduino's .ino file. Peripheral folder contains definitions for all hardware interfaces the chip supports. From my Arduino experience with I/O, UART, and I2C, I can recognize similar modules here. Let's pause here for now. Thanks for watching. See you next time.